throughout the course of the audit, I had a few different tasks. The first one was retrieving data from the humidity logger. So for this one, you could see all the lines up top correspond to the temperatures of the days that were chosen. And on Tuesday, around 10, between, I'd say 10 and 10:30, 11 o'clock, it's a rise in temperature. And there's also a rise in humidity as well. So this would correlate to when the computer lab is being used and all the students come in, body temperatures cause the rises, and speaking and the moisture of their breaths or whatever would cause the rise in humidity as well. And
Brien, just to kind of cut you off here, Matt's going to use this one, right, as his part of his opportunity. Okay. I know you did the work on this one, but
both of them are the same thing?
Well, he's going to kind of show that over a 24-hour period, the temperature in the computer lab never changes.
Alright, I didn't realize this one was for the computer lab as well. That's why I didn't take this one out. So I can take that out. So this one is the electrical load analysis for panel 12. And it was taken from February 13th to the 16th. So you can see between 1 kilowatt and a little over 2 kilowatts is the base load for the weekend. That's Saturday and Sunday. And Thursday and Friday, you see an increase in consumption around 7:30, up to 6.3 kilowatts around 10 o'clock. Around lunchtime hours, shoot straight up to above 9 kilowatts and 9.5.
So panel 12, what's on that?
Panel 12 is, see the base load at the bottom, it's the vending machines, and I'd say
the cafeteria one.
yeah.
What should we say that?
Yeah, what Brien needs to do is the same thing we talked about this morning, right? You need to make it like panel 8, put in your little brackets here and say this is this, your base load, what's part of that base load, and that's all those fridges and stuff in the cafeteria, right? And then you need to do this, and that's all of your lighting and your computers, and then this is the microwaves and stuff, and done.
I just don't know where it was.
They take an early dinner there, do they?
They do, yeah. They start early and they end early. Start at 7.
Okay, so for the next opportunity, the 10 kilowatt PV array system, and this would be used to reduce the amount of electricity being consumed from the grid. And the ideal location for the system would be to mount it on the south wall along here. So with a few numbers and a calculation tool, red screen, this is what the payback period would be, 6.5 years. With a $20,000 install cost, that's just a rough estimate of a $2 per watt installation cost. So
$2 per watt. So you're not giving them enough background with this, because obviously you've borrowed. I know this because I've seen your rescue. You borrowed $6,000. You invested $14,000. So you put a 10 kilowatt system at $2 a watt. The value of the graph on the right shows that, but you're not showing them the background, right?
6,000. What are you talking about? The 6,000? I don't remember that.
You don't remember? Well, it's $2 a watt, right? Yeah. And it's a 10 kilowatt system. So really, your cash flow at the start, if you bought it all yourself, would be negative $20,000. Right? But with this one, you're paying back the loan and invested $14,000. So this is your cash flow based off of those assumptions that you made as part of that red screen analysis.
So now you're going to be lost because you're talking about the loan.
Well, how do you buy a 10 kilowatt system at $2 a watt? That's $20,000, right?
Yeah.
You're starting off at negative 6,000.
Okay, now I see what you're saying now.
See what I'm saying?
So the 14 is in between. All right, I get what you're saying now. But
I think the way we need to sell the PV is, okay, we here's this prime opportunity. We can mount them on the wall, and therefore the wind loading is minimal. We don't have to do a ground mount. It's a really good. And if you have the Google Maps showing how perfectly this is actually oriented to the south, because it sure beats this solar air wall we have in our building. And then, like I said, what did you do yesterday? What did you calculate?
Capacity factor.
Capacity factor. For your information, these people are going to love to hear this. The capacity factor on the panels at the cast building is 11%. We've used a similar number in this analysis to determine our payback of blank. Or I think a better way for solar is internal rate of return. You know, we can take $20,000 and we can make 11% on that for the next 20 years.
I would also mention that this is at the peak time of day. This is peak consumption. So this is replacing kilowatt spot at 20 cents a kilowatt hour. Because in the middle of the day is when we hit those big peaks.
As long as we can get that peak down, you know, as long as that's
but
solar.
That's the energy we're replacing. That energy we're buying that in those peaks at 20 cents a kilowatt hour, almost 22 cents.
We got to look at, be careful how you convey that 20 cents. When you're talking about that 20 cents, it has to do with opportunities that are going to lower your 120 kilowatt peak load.
Right.
And solar, some days is going to do that, but on a cloudy day, it's not going to do it as much.
But Blair, here it's also net metered. It's not what you're creating on our panels with our system here. We're not using it to lower our peak though. It's being net metered. So it's just a credit for that. So I mean,
Yeah.
That's why we got to know that program.
Yeah, I think you're right on that, Paul.
It doesn't lower what you're consuming. It goes right to the grid, and you get a credit, and it just offsets what you spend or what you purchase.
And does it factor in the peak at all?
No, it doesn't.
Because, you know, unlike wind, which might be generating the most energy at night, this is going to be generating the most energy just at all those noontime spikes.
Yeah, for sure. Good question for Daryl. So we've got a load on the building, 120 kilowatts.
Yeah.
We've got 5 kilowatts coming in from the solar.
Yeah.
Does that offset?
Yes,
that peak
directly.
down 115?
It should directly offset at that point in time.
It should directly offset.
Yeah.
There's our...
Okay, so we can talk about that a little bit, but you just have to be cautious, right? Because it's a 1 monthly peak. So if that's not a solar day, then it's not going to be 21
And
cents.
a quick email to Frank confirming that would lower the peak if you had so many kilowatts of.
Wouldn't lower the peak, it's going to lower your consumption for that particular day, which
But the peak's over the whole year. Calculate over the whole year, right?
By month.
by month.
Okay, by month.
Right. So if you're not, so if you've got a cloudy day,
There's a good chance that's going to be cloudy during the month.
pretty good possibility, yeah. So it's, you're right, Paul, it isn't, looking at it that way, it's not going to lower the peak. It's going to lower your consumption
For that day.
for that
For the day.
for that time period,
I
yeah.
think they work it out as a credit.
And it will lower the peak a little bit because I've never seen the solar PV panel, I've never seen zero with daylight, right? So it will lower it some, but
7 days.
it's hard to say.
We had
by
pretty
how
close
much.
to zero up here with the snow covering it one day. I think it was 800 watts.
Yeah. Well, and the other
Pretty
thing,
low.
we're going to
But we
stall
wire
these at a
that
better
too.
angle than those ones.
These
And they're
guys,
going to be vertical, so there'll be no snow on them.
true.
Well, 45.
Well, nearly vertical.
So the last opportunity was exhaust fan, the heat exchange in the exhaust fan. So this one is a runaround coil and typically would be placed in the exhaust fan area and would be in the ducting or the outlet right there. You gotta decide which one would be better. So this would recover the heat from the exhaust, and because it's so close to the supply air, it would be more efficient because it's less pipe run, less distance for it to travel, so less heat loss. And it would be using glycol to prevent freeze protection and to move the heat through the system, and could greatly reduce the amount of electricity being consumed for heating purposes.
Do you mean by electricity, you mean oil?
Yeah.
But electricity as well, so I would just put in energy because you have fan energy and, but mostly oil. Okay. And you can just put in heat transfer fluid, and in brackets you can put glycol instead of typically water or freeze prevention solution. Okay. And then we need a sentence on this one saying that we can't run the numbers on this one until the other upgrades are done. Right? So it makes our job easy on this one.
Alright. That's basically it then. I'll leave that.
Okay? Right on. Thanks, Brian.